Good afternoon. I am Pooja Bhanot, lecturer in chemistry from Pandit Jagatram Polytechnic College, Hoshiarpur. Today I am going to discuss the topic that is fuel and its characteristics. So let us discuss what is fuel. So what topics I am going to cover here, that is what is fuel, and then what is the combustion of fuel, then classification of fuel, calorific value, characteristics of good fuel, and then I am going to revise this topic in terms of multiple choice question. So, this is the brief summary of the topics which I am going to discuss in today's lecture. So, let us discuss what is fuel. The combustible substances which on burning in air produces large amount of heat that can be used economically for domestic and industrial purposes are called fuels. For example, wood, coal, etc. As we all know that heat energy is very important for doing the work. In the case of human body also, we require energy, and that energy we get from food, and when it oxidizes then it produces large amount of energy for the body. So, in the similar way as the food is the fuel for the body, so the today's era is a machine era where the power is required to generate energy, and this power we get from heat energy. So, in the natural substances where this heat energy has been reserved are called the fuels. So, what are the fuels? These are the combustible substances on burning of which produces large amount of heat, and this heat we can use for domestic and industrial purposes. And example, as we all know, is wood is one of the common example, then coal is also the example. So, let us discuss the what is the combustion of fuel. The term combustion refers to the exothermal oxidation of fuel by air or oxygen occurring at a sufficiently rapid rate to produce high temperature, usually with the appearance of flame. So, what is combustion? Combustion is the exothermal oxidation. As we all know, what is exothermic reaction and what is endothermic reaction? The exothermic reactions are those reactions where the energy is released, and endothermic reactions are those reactions where energy is absorbed. So, combustion is a exothermic oxidation, that means this is the burning of the fuel in the presence of oxygen and there is a liberation of large amount of energy. Therefore, this is known as exothermal oxidation. So, I have discussed this combustion of fuel. As most of the fuels contain carbon or carbon and hydrogen, the combustion involves the oxidation of carbon to carbon dioxide and hydrogen to water. So, during combustion what happens, as the fuel is containing carbon and or carbon and hydrogen. So, carbon is getting oxidized to carbon dioxide and hydrogen is getting oxidized to water. Sulfur, if present, is oxidized to sulfur dioxide, while the mineral matter which is present in the fuel, that forms the ash. The complex fuels like coal undergo thermal decomposition during combustion to give simpler products, which are then oxidized to carbon dioxide and water. So, these are the changes which are occurring during the combustion, that is the elements which are present in the fuel like carbon, hydrogen, sulfur, they are getting converted into carbon dioxide, water and sulfur dioxide respectively. And what about the mineral matter? The mineral matter, if present, that is converted into ash. What is ash? Ash is the non-combustible matter which is left after the combustion. So, the complex fuels like coal, they undergo thermal decomposition during combustion to give simpler products, which are then oxidized to carbon dioxide. Let us see what happens in the case of complex fuels. For example, the coke on combustion gives carbon dioxide. So, what I have said, that coal being the complex fuel that is getting converted, first change which is occurring, that is it is getting converted into coke plus coal gas, then coke, that is carbon, that is getting oxidized to carbon dioxide. So, in the case of complex fuels, what is happening in the first step? They are getting converted into simpler substances which are then oxidized to their respective oxides. So, these are the major changes which are occurring during combustion. So, now let us discuss the classification of fuel. So, fuel can be classified on the basis of their occurrence and physical state. So, with the help of this flow chart, I have simplified the classification, that is the fuel, they can be classified on the basis of the occurrence, that is how do they occur in nature, and on basis of their physical state. So, let us discuss, depending upon the occurrence, what are the types of fuels. On the basis of occurrence, the fuel is of two types, that is primary or natural fuel, then secondary or artificial fuel. So, I have already discussed that the fuel can be classified on the basis of their occurrence and physical state. So, on the basis of the occurrence, what are the types of fuels? One is primary or natural fuel, then secondary or artificial fuel. So, let us discuss these two types of fuels in detail. So, on the basis of the occurrence, the fuels are of two types, that is primary fuel and secondary fuel. So, what are primary fuels? The fuels which occur naturally, such as coal, crude petroleum and natural gas. So, those fuels, the primary fuels are those which are occurring in nature naturally. So, these are the examples are coal, crude petroleum, natural gas. Coal and crude petroleum formed from the organic matter many millions of years ago, and they are referred to as fossil fuels. So, these coal and crude petroleum, which are the primary fuels, how they are formed? They are formed from the organic matter. Okay? And from the organic matter, when they are buried under the earth millions of years ago, then they are converted into the fuels. So, these fuels are called fossil fuels. So, what are secondary fuels? Let us discuss it. The fuels which are derived from naturally occurring ones by treatment process, such as coke, gasoline, coal gas, etc. So, secondary fuels are those fuels which are derived from naturally occurring fuels, that is which are derived from primary fuels via the chemical treatment process. So, what are the examples of secondary fuels? The secondary fuels are coke, gasoline, coal gas, etc. So, I have discussed the both types of fuels on the basis of the occurrence. Now, it may be very clear that primary fuels are coal, petroleum, natural gas. Secondary fuels are coke, gasoline and coal gas. On the basis of the physical state. So, fuel can be divided into three types, that is solid fuel, liquid fuel, then gas. So, let us discuss this. I have shown the classification of fuel with the help of these flow charts. So, on the basis of the occurrence, the fuel are of two types. As you can see in this flow chart, the fuels are of two types. One is primary fuel, second one is secondary fuel. And I have discussed here that primary fuels are those fuels which are derived from, which are present in the nature, and secondary fuels are those fuels which are prepared artificially from the primary fuels. Now, on the basis of physical state, the primary fuels are of further three types. In the similar way, the secondary fuels are of also three types. So, primary fuels are solid, liquid, gas. So, in case of primary fuel, what is the example of solid primary fuel? That is wood, peat. Liquid primary fuel, that is crude oil. Gaseous primary fuel, that is natural gas. Here you can see this in flow chart. Then secondary fuel, the solid secondary fuel is coke, charcoal. Liquid secondary fuel, this is petrol, liquefied petroleum gas, that can be written as LPG. Gaseous secondary fuel, that is coal gas, water gas, etc. So, there are mainly two types of fuels on the basis of occurrence, that is primary, secondary, and on the basis of the physical state there are further three types, that is solid, liquid, gas. In this way I have discussed in brief the classification of fuels. Next topic which I am going to cover, that is characteristics of good fuel. So, first characteristic of a good fuel. So, what are the characteristics of good fuel? A fuel which can be used, that is having its good characteristics, that is quite safe to use. So, that fuel is a good fuel. So, one of the characteristic of a good fuel is high calorific value. A good fuel should have high calorific value, that is it should produce large amount of heat on burning. So, let us discuss what is calorific value. I have already said that for a fuel to be a good fuel, its calorific value should be very high. Then what is a calorific value? The calorific value of a fuel is defined as the quantity of heat expressed in calories, that is the unit of heat, or kilocalories. So, calorific value of a fuel is defined as the quantity of heat liberated by the complete combustion of unit weight, that is it can be 1 gram or it can be kilogram, unit weight of the fuel in air or oxygen with subsequent cooling of the products of combustion to initial temperature of the fuel. So, what is calorific value? This is in simple way I can say that this is the quantity of heat liberated when there is the combustion of a unit weight of fuel in air or oxygen. So, calorific value is the amount of heat produced. The calorific value of a fuel depends upon the nature of fuel and the relative proportion of elements. So, on what factors the calorific value depends? This depends on the nature of fuel and the relative proportion of elements present. Increasing with the increasing amount of hydrogen, the moisture if present considerably reduces the calorific value of a fuel. The calorific value may be theoretically calculated from the chemical composition of fuel. So, on which factors the calorific value depends? It depends on the nature of fuel and it depends upon the relative proportion of the elements. And if the proportion of element like hydrogen is increasing, then calorific value is also increasing. But if the moisture is present in the fuel, then calorific value decreases. So, the calorific value can be calculated from the chemical composition of the fuel. If both hydrogen and oxygen are present, it may be assumed that all the oxygen they are already combined with 1 by 8 of its weight of hydrogen to form water. This fraction is then deducted from the hydrogen content of the fuel in the calculation. Thus, for a fuel containing carbon, hydrogen, oxygen and sulfur, the calorific value of the fuel is given by Dulong's formula. So, I have already discussed here that calorific value can be calculated from the chemical composition of the fuel. So, one of the important formula for the calculation of calorific value is Dulong's formula. So, what here it is written, if the both hydrogen and oxygen are present, so it is assumed that oxygen reacts with 1 by 8 of its weight of hydrogen to form water. So, that fraction is deducted from the hydrogen content. So, what is the formula of Dulong? That is determination of calorific value from Dulong's formula. 1 by 100 calorific value is equal to 1 by 100 8080 into C. C is the carbon content plus 34500 bracket start H. H is the hydrogen minus oxygen over 8 bracket close plus 2240 sulfur, that is S is sulfur, kilocalorie per gram. So, where carbon, hydrogen, oxygen, sulfur refers to the percentage of carbon, oxygen, hydrogen and sulfur respectively. So, carbon, hydrogen, oxygen, sulfur refers to the percentage. So, if you know the percentage of carbon, percentage of hydrogen, percentage of sulfur, then percentage of oxygen, then you can find out the calorific value of a given fuel by using this formula. So, this formula is Dulong's formula. Now, there are two types of calorific values. One is gross calorific value, second is net calorific value. So, let us discuss these calorific values. With the fuels containing hydrogen, two calorific values are distinguished, the gross and the net calorific value. So, the gross calorific value is, the gross calorific value refers to the heat evolved when the water produced by the combustion is condensed as a liquid. The net value gives the heat liberated when water is in the form of steam or water vapor is allowed to escape. Thus, the gross calorific value or the higher heating value is the quantity of heat liberated by the complete combustion of unit weight of fuel with subsequent cooling of the products of combustion to initial temperature of the fuel. Under normal working conditions, the water vapors produced during combustion are not condensed and they escape as such along with the hot gases. Hence, the lesser amount of heat is available, which is called lower or net calorific value. So, the net calorific value is the heat produced when unit mass of the fuel is burnt completely and the products of combustion, they are allowed to escape. So, what is the difference between gross calorific value and net calorific value? So, as we all know, the fuel contains hydrogen. So, that hydrogen can be oxidized to water, to steam during the combustion. So, when this steam is allowed to condense under to a room temperature conditions, then the latent heat of condensation is evolved, and this heat is also included in the gross calorific value. But in the case of net calorific value, what we are assuming that the water in the form of steam which is produced during the reaction, during combustion reaction, is allowed to escape. So, the latent heat of condensation which is evolved during the combustion, that is not considered in the combustion reaction. So, the gross calorific value is higher than net calorific value, because in case of gross calorific value we are also considering the latent heat of condensation of water vapors. But in the case of net calorific value, what we are assuming that these water vapors, they escape, and this latent heat of condensation of water vapors is not considered in the value. So, the gross calorific value is always greater than net calorific value. Therefore, the gross calorific value is also called higher calorific value, while the net calorific value is called lower heating value. So, net calorific value is defined as the gross calorific value minus the latent heat of condensation of water vapors at the initial temperature of the fuel formed by the combustion of hydrogen in the fuel. The latent heat of steam at ordinary temperature may be taken as 587 calorie per gram. So, what is the difference between the gross calorific value and net calorific value? In the case of gross calorific value, when the hydrogen is oxidized to steam during the combustion, that steam is allowed to condense under the normal temperature conditions, room temperature, and that then the latent heat of condensation of water vapor is evolved. That heat is also included in the gross calorific value. But in case of net calorific value, what we are considering, that water vapors which are formed during the reaction, that are allowed to escape. So, there the latent heat of condensation of water vapor is not considered. So, what is the difference between gross calorific value and net calorific value? Gross calorific value minus latent heat of condensation of water vapor, that is the net calorific value. So, the gross calorific value is also called higher heating value, while the net calorific value is called lower heating value. So, what is the formula to find out the net calorific value? The net calorific value is equal to gross calorific value minus the latent heat of water vapors. So, NCV is equal to GCV, that is gross calorific value, minus the weight of hydrogen into 9 into latent heat of water vapors. So, the latent heat of water vapors is 587 kilocalorie per gram. So, let us discuss the calculations in detail. Hydrogen in the fuel reacts with oxygen to give water. So, hydrogen is reacting with half molecule of oxygen to form H2O, one molecule of water. So, what we are taking up from the reaction, that is 2 parts of hydrogen react with 16 parts of oxygen to form 18 parts of water. So, let us take the common factor out, that is 2. What we have got from this reaction, that is 1 part of hydrogen reacts with 8 parts of oxygen to form 9 parts of water. So, let us use this in the calculations part. Let H is the percentage of hydrogen in the fuel. The amount of water produced by burning unit mass of fuel, that is equal to 9 into H percentage of hydrogen over 100 gram. Latent heat of steam, the value is 587 calorie per gram. The amount of heat produced by the condensation of steam is 9H over 100 into 587 calorie. So, 587 is the value of latent heat of condensation of steam. So, what is the amount of water which has been produced during burning? Unit mass of fuel, this is 9H over 100. So, what is the total amount of heat which has been produced is 9H over 100 into 587 calorie. So, net calorific value is equal to gross calorific value minus 9H over 100 into 587. So, this I have already shown in the above calculation, that how this factor is coming, that is 9H over 100 into 587. So, the formula which we have got from for the net calorific value is equal to gross calorific value minus 0.09 into 587 calorie per gram. So, this formula we have got by doing the above calculations. So, what is the relationship between net calorific value and gross calorific value is gross calorific value minus the latent heat of condensation of water vapor is equal to net calorific value. I hope you have understood the what is calorific value and what are the two types of calorific value, that is gross calorific value, net calorific value, and how we can calculate this calorific value from the Dulong's formula. Then I have discussed the calculation to determine the net calorific value from gross calorific value by subtracting the latent heat of condensation of water vapor. So, what is moderate ignition? What is ignition temperature? So, what I was discussing the characteristic of fuel, in which I have discussed the first point that a fuel should have high calorific value. Then I have discussed what is calorific value. So, that was the first characteristic. Now, I am going to discuss the second characteristic, that is ignition temperature. So, what is the second characteristic of a good fuel is it should have moderate ignition temperature. What is ignition temperature? The lowest temperature to which a fuel must be preheated so that it starts burning smoothly. So, this is the lowest temperature to which a fuel must be preheated. If the ignition temperature is low, then fuel catches fire easily. So, low ignition temperature is not desirable because it is very dangerous for the storage and transportation of the fuel. So, high calorific, if there will be high ignition temperature, then it will not be good because it will cause the difficulty in kindling. So, a good fuel should have moderate ignition temperature. So, this what is ignition temperature? This is the lowest temperature to which a fuel must be preheated so that it starts burning smoothly. So, if the ignition temperature is low, then also it is not desirable. If it is high, then also it is not desirable. So, what is the characteristic of a good fuel? It should have moderate ignition temperature. So, what is the third characteristic of a good fuel? That is about the moisture content. So, a good fuel should have low moisture content, as the moisture content reduces the calorific value. Then it is about non-combustible matter content. So, what is the fourth characteristic of a good fuel? That is, it should have low non-combustible matter content. A good fuel should have low contents of non-combustible matter material as